Okay, question number 7. A kite in the shape of a square with diagonal 32 centimeter and an isosceles triangle. You can already see here at the base here, right? So this is an isosceles triangle, all right? Of base 8 centimeter, all right? So here, this isosceles triangle here, the base is how much? 8 centimeter, all right? And sides 6 centimeters. So in an isosceles triangle, two sides are equal. So the other two sides are what? EC equals 6 centimeter and then CF equals 6 centimeter, right? How much paper of each shade has been used? So when you look at this criteria, do you see it is divided in three parts, right? This is the first part, this is the second part, and this is the third part. So they're just asking us how much paper of each shade has been used. So we simply have to find the area. Okay, how much is area 1 equal to, how much is area 2 equal to, and how much area 3 is equal to. All right, so let's start. So here you will notice a what they've only given us a diagonal of a square. If we try to find the area of the square, it was supposed to be side square, right? That is if we know all the sides. Okay, if we know all the sides, but you'll notice here the sides has not been given. Okay, but there's another way to find out. That is simply by just writing area of the square half times diagonal square, or half times d square. Okay, so you can see a diagonal given, diagonal of the square. If you look at a diagonal, that is what AC and BD, right? How much they've given us? The question is given to us to be equal to 32. And like I said, area of the square can be written as half times diagonal square. Okay, d square. Then 2 1s are, and 2 1s are, 2 6 are 12. We'll be multiply 16 into 32. We're going to get 512 centimeter square. That means the whole area of this is how much? 512 centimeter square, right? But we know that what diagonal of a square divides it into equal area. So if we just consider this diagonal, okay, then we have this area and this area equal. Or if we consider this diagonal here, which we'll be doing here, then this area and this area are equal. Because of the diagonal, it is divided into equal parts. All right, so that is how I'm writing it down. Therefore, area of triangle ABD, so this is the first area, right, should be equal to area of triangle, right down here, area of triangle. Okay, right down here, area of triangle CBD. So CBD, like I said, the whole area is almost 512, right? And now this BD divides it into equal half. So you can see 512 divided by 2. So how much do we get once we divide? We're getting 256, which means this area 1 is 256 centimeter square, and this area 2 is also 256 centimeter square. Now that we know, we just have to find a third part, that is the area of this triangle, area of this isosceles triangle. I already told you how the sides came, right? Base given to us, and the two equal sides are 6 and 6. So here, when you look here in this triangle CF, we already know the three sides, which means we just have to find the semi-perimeter. Okay, you can see I'm taking, this is A, this is B, and then this is C. All right, so next we have to find the semi-perimeter, right? A plus B plus C by 2. So if you add all this, we're going to get 6 plus 8 plus 6, we're going to get 20 by 2. If you divide, we're going to get here 10 centimeter. We know the semi-perimeter, we just have to use what Heron's formula, right? So you can say everything the Heron's formula here. Then 10 minus 6, 10 minus 8, 10 minus 6. Then 10 minus 6 will give us 4, 10 minus 8 will give us 2, and then 10 minus 6 will give us how much? 4. Okay, next this 10 can simply be written as 2 into 5. All right, then this 4, just leave it as it is, and then same thing with this 4. Then do we have here 2 square and then 4 square? We have, right? So I've written it down here. They will both come out. 2 4s are 8. Root over 5 will be inside, and if we try to find the value of this root over 5, okay, we have to find a square. So we'll start with 2. 2 2 is 4. Then 5 minus 4 is 1, right? Then 2 2 is 4 will be taking. You can see 4 is greater than 1, so point. Then like I said, 2 0 will come down. Then here we'll take 40 2, right? 2 to 4, we're going to get 80 4, right? So 2 times we're going to have here 84, and 10 minus 4 will have 6, and 8 1. Next 22, we have to always multiply by 2, right? 22 into 2, we're going to have 44. All right, then once again 44 is greater than 16, so 2 more 0 will come. So let's try with 4 4. Then like I said, whatever you take, you have to multiply with the same. 3 3s are 9, 3 4s are 12, 3 4s are 12, 13, right? So 3 3, then I'm going to have a 1 3 2 9. All right, then 10 minus 9, 1 2 3 4 5 6 7 8. So we're gonna have what? 9, right? Then 7 3 4 5 2. Okay, then once again, 223 by 2, so 3 to the 6, 2 to the 4, 2 to the 4, so we're going to have 4 4 6. Once again, this is so much better, so again double 0, right? Then 4 4 6, we'll take it 6 times. Okay, so if we take it 6 times, how much do we get? We'll get 4 4 6 6 divided by 6. 6 6 36, 6 36, 39, 6 4 24, 25, 26, 27, 6 4 24, 25, 26, right? 2 6 7 9 6, and let's not go more in this. Okay, so you can see here what root over root over 5, how much do we get? 2.236, but we're taking approximately. Okay, so that is why instead of writing 2.236, it has become 2.2 4 here, right? Multiply these two, and that's how we're going to get the region of the third area to be equal to 17.92 centimeter square, which is the third area.